Hey, my name is Yathaman Srilesh and I'm the co-president of the YSL. Today's video is going to be on simple differentiation, and today we're going to be going over the power rule. Um, in future videos, we'll be going over more advanced topics like quotient rule, product rule, and other types of differentiation. But today we're going to start with the basics on the power rule. So, what is the power rule? So, the power rule is going to be used to take the derivative of polynomials. And we can take a polynomial is going to be in the form of x to the n. So here's the formula for the power rule. It's going to be the derivative of x to the n is equal to n times x to the n minus 1. So what does this mean? This formula looks kind of disgusting. So how can we make sense of this? So let's take an example. Let's say f of x equals x squared. Given that f of x equals x squared, how can we take the derivative? So, according to our formula, we're going to take our exponent and bring it down like this. And notice how we have n in the front as our coefficient, and then and then we're going to subtract the exponent by 1. So, what would the derivative? I'm going to use it. I'm going to use this type of notation to show a derivative. I'm going to use an apostrophe instead of the d over dx. So f prime of x is going to be equal to 2, bring the exponent down, x, and then we're going to subtract the exponent by 1. So what is 2 minus 1? It's going to be 1. So, and then x to the 1 is just 1. So the derivative of x squared is equal to 2x. Sorry. Let's try a few more examples. Let's try this. So what is the instantaneous rate of change of the function of 2x to the sixth? Okay, so 2x to the sixth. Let's apply our formula. So f of x equals 2x to the sixth. Now when we're going to take the derivative, we're going to bring our exponent down. So here we have a leading coefficient. What we're going to do here is we're going to, according to our formula in the last slide, we multiply the leading coefficient 1 by n. We can have a 1 in front because multiplying by 1 doesn't do anything. So here we have a 2 instead. So we're going to do 6 times 2. So 6 times 2 times x, and then we're going to subtract the exponent by 1. So 6 minus 1 is 5. And now we're going to multiplying our coefficients. And what's 6 times 12? It's going to be 12. So our derivative of 2x to the sixth is 12x to the fifth. Okay, so next we have a little bit more complicated polynomial, but I want you to try this on your own. So I'm going to rewrite this. F of x equals 3x to the fourth plus 1/2 times x squared plus 3. Notice 3 doesn't have an x or a variable, but we can add on x to the 0. Technically, the 3 does have a variable term, and that's going to be x to the 0. What is anything raised to the 0 power? It's going to be 1. And 3 times 1 is 3. So our polynomial still remains true. And so whenever you see a constant, remember there's always a x to the 0, or whatever the variable is, to the 0th power. So now let's apply our power rule. So f prime of x is going to equal. So let's we can add the derivative of each of these terms. So what's the derivative of 3x to the fourth? We're going to multiply 3 times 4, which is 12. And then we're going to subtract the exponent by 1. So we get 12x cubed. And then plus, then we're going to do the same. So so 1/2 is our leading coefficient. Our coefficient for the quadratic term. So then we're going to multiply by 2, our exponent. So 1/2 times 2 is 1. And we're going to subtract the exponent by 1, which is once again 1. So we're just going to have 1x to the 1, which is just x. And then we're going to take the derivative of 3x to 0. When we take down 0 to the front, 0 times 3 is just 0. So this is going to be 0. The derivative of any constant term is always going to be 0. This is important to know. So our final answer is this, 12x cubed plus x. Okay, next we have a little bit more tricky example. Let f of x equal the square root of x. What is the derivative of f of x? So, you guys might be confused, thinking, how could this be a power rule problem? Clearly, we don't see any exponents. I encourage you to pause this problem and try this on your own first. So first, I'm going to rewrite the square root of x as x to the 1/2 power. Recall that fractional exponents can be written as square roots, and the fractional form of this of square root is 1/2. So now we're going to apply our power rule once again. So we're going to bring this to the front and multiply it by our coefficient, which is 1. So 1/2 times 1 is just 1/2. Then x, 1/2 x, and then what's 1/2 minus 1? It's going to be negative 1/2. So now we have a negative exponent. Remember that to make a negative exponent positive, we're going to take the reciprocal of that term. So 1/2 times the reciprocal of x, which is going to be 1 over x to the 1/2. So remember how our negative exponents work? We're going to bring it to the denominator and keep our exponent. And then I'm going to rewrite the square root, 1/2 of the exponent 1/2 as square root of x. So our final answer is going to be 1 over 2 times the square root of x. Oops. Okay, next. What is the instantaneous rate of change of the function 1 over x cubed? So let's write our function. F of x equals 1 over x cubed. So I'm gonna so once again we're asked to find the instantaneous rate of change. So how would we do this? So let's rewrite 1 over x cubed as a negative exponent. So x cubed is equal to 1 over x cubed is equal to x to the negative third power. Because remember, we just take our exponent to the denominator if we have a negative exponent. So these quantities are the same. So then, when we take the derivative, we're going to take the exponent to the front. So 1 times negative 3 is 3. Then x, and then we're going to subtract our exponent by 1. So negative 3 minus 1 equals negative 4. So negative 3 times x to the negative fourth. So, and then, once again, I'm going to make our exponent positive. By bringing it to the denominator, we get negative 3 over x to the fourth as our final answer. Okay, now we're going to be finding the instantaneous rate of change at x equals 3. So what does that mean? Basically, we're going to be finding the slope of the tangent line for this polynomial when its x value is equal to 3. So after we find our derivative, we're going to plug in x equals 3. So you can write this as, so let's write our function first, f of x equals 3/5 x to the 5th minus 5/4 x to the 4th. Now I'm gonna switch our notation to d over dx notation. So d over dx at x equals 3 of f of x. So this just means the derivative of f of x at x equals 3. I apologize for the handwriting. It's a little bit hard to write on the mouse. Okay, so we're going to take the derivative of each of these terms like we did earlier. So we're going to take the exponent and then we're going to bring it down to the coefficient. So 3/5 times 5. What is 3/5 times 5? By multiplying by fractions, we get equals 3. So 3x to the 4th, because we subtract our exponent by 1. And then minus 5/4 x to the 4th. The derivative of that is when we have to multiply 4 with our coefficient. 5/4 times 4 is 5. And then we're going to subtract our exponent by 1. And this is going to be at x equals 3. Okay, so now we have our derivative. And now this is going to be, now we want to plug in 3. So we're going to do 3 times 3 to the 4th minus 5 times 3 cubed. Now, we're going to evaluate this polynomial. So 3 to the 4th is 81. And then, so we're going to do 3 times 81 minus 5 times 27. And we can actually factor out a power of 3 here to make our computation a little bit easier, if you'd like. But I'm just going to compute it regularly. 3 times 81 is 243. Minus 5 times 27 is 135. And subtracting both of those gives you 108. And that's our answer. So thank you so much for watching this video. In the next video, we'll be going over more advanced differentiation techniques and applications of derivatives. Thank you.